A 50 centimeter long solenoid has 400 turns per centimeter. The diameter of the solenoid is 0.04 meter. Find the magnetic flux linked with each turn when it carries a current of 1 ampere. The coil is given, the solenoid is given, which carries a current of 1 ampere and it has 400 turns per centimeter and its length is 50 centimeter and the diameter is 0.04 meter. All these data are given in the problem. Let us picturize it. Good. Now let us go for the flux. This is what the flux produced by the current in the coil. We need to find the total flux by the solenoid. Next, we have to find what is the flux per turn of the solenoid. Next, we have to go with the formula. The flux phi equals L times I. L is the self-inductance of the coil. I is the current flowing through the coil. What is L? The self-inductance. L equals, for air core coil, it is mu naught N square A by L. What is mu naught? The permeability of air. N, the number of turns of the coil. A, the area of cross section of the coil. L is the length of the coil. The solution. Let us start with the length. Length is given in the problem as 50 centimeter. We have written it is in SI unit. L equals 50 into 10 power minus 2 meter. So the number of turns per centimeter is given in the problem. It is 400 turns per centimeter, but we have 50 centimeter. So we have to multiply this 400 by 50 to get the total number of turns in 50 centimeter, which is equal capital N, 20,000 turns. There are 20,000 turns in 50 centimeter length of the solenoid. That's we write it as N equals 2 multiplies 10 power 4 turns. Next, the diameter of the coil is given as 0.04 meter. Let us find the radius. This is half of this time. Using this radius, we can find the area equals pi r square. Pi is 3.14, r is 2 into 10 power minus 2 times. Multiplying this, we get the area of the coil equals 12.56 into 10 power minus 4 meter square. Let's write this separately here. Then what is the current flowing through the coil? That is I. I equals 1 ampere. Good. Now the magnetic flux linked with the solenoid, not the turn of the coil, solenoid, we have the formula phi equals L times I. Here on the left hand side you don't have N term here, right? Good. You have to remember that. Let us substitute L, mu naught N square A by L times I. So let us not, we need some space. Let us remove few terms from here. Good. So phi equals mu naught is 4 into 10 power 4 pi into 10 power minus 7 and N is 2 into 10 power 4 2 times. Area is 12.56 into 10 power minus 4 divided by the length is 50 into 10 power minus 2 and the current is 1 ampere. We are going to simplify this. 4 times 2, 8. 8 times 2, 16. Then you have 3.14 and 12.56 on the numerator. And the denominator you have 50 into 10 power minus 2. Multiplying the numerator and denominator by 2, we get 100 in the denominator to 10 power minus 2. Totally the denominator becomes 1. So then we have simply multiplying the numerator term to get the phi. That is equal to 1.26202 Weber. That we write it separately. Alright, this is the flux through the solenoid, but we are asked to find the flux per turn. The flux per turn is given by small phi equals capital Phi divided by capital N, the total number of turns. So capital Phi equals 1.26202 divided by the total number of turns 2 into 10 power 4. By dividing this, we get phi, the flux per turn 0.63 into 10 power minus 4 Weber per turn. Thank you, children.